The operator is basically anything that's not white space, isn't keyword, and isn't an identifier. And there are many types of operator, and the first one, assignment operator, which are used to assign values to the variables, as we saw in previous video when we was declaring variable and assign actual values. For example, here in mathematics we say a equal to 15, but actually in the programming we have to say the value 15 assigned to the variable a. Don't forget that, and that's all for the assignment operators. And now with the second type, which is arithmetic operators, which are used to perform mathematical operations like addition, subtraction, multiplication, and division. For example, if I assigned 10 to the variable b, then the addition will be like that, and the result will be 25, and the subtraction the same, and the result 5. And for the multiplication also the same, and the result 150. But in division there are two types of division. The first one, float division, which is the normal division, like this: a divided by b, and the final result it will be 1.5. And in the second type of division, which is float division, which is normal division operation, except that will return the largest possible integer. This integer is either less than or equal to the normal division result. For example, as we can see, the result it will be integer. In other words, the float division will the result of float division will be the integer part, and the point and the numbers which is after the point will be ignored. And now with the last type of arithmetic operators, we will talk about the modulo. The modulo means the reminders of dividing, which mean a mod b, then the result it will be 5. And that's all for the arithmetic operators, and now we will talk about the relational operator. Actually, the relational operator compares the values, and the result it will be Boolean, which means true or false. For example, a equal to the same one, 15, and b equal to 10. But first I will mention which is the operation, which is the relational operator. The first one, greater than, then less than, equal, not equal, greater than or equal, less than or equal. So with the first one, if we say a greater than b, then I will get true. If we write a less than b, then I will get false. And the same thing for the equal, then I will get false. A not equal b, then I will get true. The same thing with larger than a, larger than b, then I will get true, and less than I will get false. But if I write b less than a, I will get true. And that's all about the relational operators. And now we will move to logical operators. The logical operators perform logical and logical OR and logical NOT operations. For example, if I assign the true to A and false to B, then A and B, I will get false because I will get true with the end if the both of expressions are true, except that I will get false. And as we can see, A true and B false. And now with the OR operator, here I will get true because I get false just if the both of value are 0 or false. If one of the value true, then the result it will be true. And now with the not operator in the logical operator, I will get, for example here, not A equal to true, then I will get false. B equal to false, then I will get true, which means the opposite of the expression, the result of the expression. And now we'll move to the third type, of the fifth type of the operator, which is bitwise operator. Actually, the bitwise operator acts on bits and perform bit by bit operation. For example, A equal to 10, B equal to 3. Then, also before that, I have to mention the operation, which is bitwise AND, bitwise OR, bitwise NOT operation, bitwise XOR operation, bitwise right shift operation, and finally bitwise left shift operation. So with the first one, bitwise AND operation, here I will get 2, and that's because in the AND, as we mentioned, we get true in case the both of expression are true, and here if the both of the bits are 1, then I get 1, except that I will get 0. And here 10 in the binary representation equal to, from left to right, 1 0 1 0, and 3 equal to 0 0 1 1. And when we apply the AND operation, then I will get 0 and 1, it will be 0. 1 and 1, it will be 1. 0 and 0, 0. 1 and 1, 1 and 0, it will be 0. And so the final result, it will be 0 0 1 0, which is 2. And now with the bitwise OR operation. Here the result is 11, and that's because I will get 1 in case one of the bits equal to 1, and I will get 0 just if the both of bits equal to 0. So here, as we mentioned, 1 0 1 0, 0 0 1 1, then 0 1 1 1 1 1, 0 0 0 1 0 1. So the final result, it will be 1 0 1 1, which means 11. And now with the bitwise NOT operation, which is like that. Actually, the NOT operator yields the bitwise inversion. The bitwise inversion of x is defined as minus x plus 1 at the following. And if we try to do that with the A, we will get minus 11. And now with the fourth type of bitwise operator, which is XOR, and with XOR we get 1 in case one of the bits are 1, but if the both of bits are 0 or 1, then I will get 0. So here I will get 9, and that's because 0 equal to 0 XOR 1, I will get 1. 1 XOR 1, 0. 0 XOR 0, the result 0. 1 XOR 0, 1. So the final result, it will be 1 0 0 1, which is 9. And now with the bitwise right shift operation, which means shift the bits of the number to the right and fill 0 on the on voids left as a result. For example here, A, then shift just 1 bit, and the result, it will be 0. The result, it will be 5, and that's because the A equal to 1 0 1 0 1 0, and I will shift to the right, which means every bit will move to the right, and I fill the left side with 0. And the first and now with the bitwise left shift operation, here the opposite, which means shifts the bits of the number to the left and fill 0 on voids right as a result. For example here, if I did the same, then 1, then I will get 20. So the same operation with the right, but in the opposite way. And now we will move to the special operator, and which is the last type of operator in Python. And this special operator divided to two types. The first one, identity operator, which is and is not. And these two operators are the identity operator, which is used to check if variable point to the same object in memory. For example, if I will declare A equal to 10, then B equal to 10. Then here A is B, I will get true. For example, C equal to 3, A is C, then I will get false. But we have to note that the two variables that are equal doesn't imply that they are identical. For example, A equal to 1000 and B equal to also 1000, then I will get false. So why? Actually, everything in Python is an object, and the objects are stored at specific memory location. But Python is efficient and uses the same memory location for certain objects. For example, short strings or integer between -5 till 256. So here the number larger than 256. So for that it will be equal but not identical. And we can check if the identity of the object by the ID function. For example here, the ID of A and the ID of B. As we can see, they have different ID. What about, for example, the first one? For example, A equal to 10 and B equal to 10. Then, if I check the ID, the identity A and ID B, then I will get the same object, which means the A and B in this A and B in this case point to the same object in the memory. And now, with the last type of special operator, which is membership operator, which are in and not in. And these two operators used to test whether a value or variable in a sequence. For example, if I want to declare, for example, x equal to hello Shabby, then I want to check if the letter O exists in this string or not. So O in x, then I will get true. But if I want to check, for example, Z, I will get false. And the same thing for in and not in. For example, Z equal to Z, then Z not in X, then I will get true. And if tried with the O letter, I will get false, not in X. So that's all about the operator in Python. I hope that was useful. Thank you for your watching, and now we will move to execution, the condition execution and the loops.